And then you just set this up real fast. Sorry, I just got to set up the live stream thing. All right. Couple more people coming in, so I'll just give it a few more minutes here. Awesome. Setting up the live stream, then it does this weird thing where you'll start to hear an echo, and I'm just going to try to get rid of that first. All right, perfect. Now we've got everything going. Okay, thank you all for coming. I'm super excited about this talk. And if you are trying to get CE credit for this, CE credit is only given for watching and participating with the live lecture. The recorded lecture will not give you CE credit. And in order to ensure you get credit and a certificate, you'll have to fill out the course survey, and I'll put that link in the chat towards the end. And then when you click the submit button, then your CE certificate will pop up, and it won't have your name or anything. You'll have to fill that in yourself. And you can also email me at info@ourhonor.org if you need it, or if you have any questions. We also want to keep these continuing education courses free and accessible to everybody. So if you are able to donate, please do. We accept Venmo at Our Honor, or you can go to ourhonor.org/donate. And without further ado, Mickey Pardo is a behavioral ecologist with a strong background in animal communication and cognition. He received his bachelor's degree in environmental biology from SUNY College of Environmental Science and Forestry. He earned his PhD in animal behavior from the Department of Neurobiology and Behavior at Cornell University, where he studied vocal communication and social cognition in both wild Asian elephants and acorn woodpeckers. He then completed an NSF postdoctoral fellowship at Colorado State University studying vocal communication in African elephants. He is currently a postdoctoral associate in the Yang Center for Conservation Bioacoustics at the Cornell Lab of Ornithology, where he is using passive acoustic monitoring to study threatened bird populations in Southern California. So take it away, Mickey.
Thanks. Thanks for that introduction. And thanks to all of you for being here and for inviting me, Dr. Heath. I'm just going to share my screen. So let me know if you can see that.
Yep, looks great.
Cool. Okay. All right. So I'm going to talk today about some of the scientific research that's been done on chicken cognition, and then also discuss its implications for chicken welfare. So a little bit of background. As you probably know, chickens are by far the most common farmed animal on the planet. About somewhere around 74 billion are killed per year for food production, and that number is increasing. So it's projected to be about 85 billion by 2032. But despite the ubiquity of chickens, they're rarely thought of in individual terms. And when people do think of chickens, they typically think of them as not very intelligent. But studies have shown that we often underestimate the mental capacities of animals used for food. So for example, in one experiment, people ascribed reduced mental capacity to sheep and cows when they were prompted to think about eating meat. And doing so, that is, seeing these animals as less intelligent reduced the degree to which the participants felt bad about eating meat. So that suggests that our perceptions of chickens may not be based in reality so much as they're based in a psychological defense mechanism to essentially protect ourselves from feeling negatively about harm caused to chickens. So in this talk, I'm going to talk about three basic areas of cognition in chickens. The first is mathematical and logical reasoning. Then I'll talk about social intelligence and communication behavior. And then finally, I'll talk about some internal states related to consciousness and self-awareness. And then I'll discuss some of the welfare issues that are endemic to agriculture, the way chickens are treated in agriculture. And then I'll briefly discuss what I think are some of the ethical implications of all of this information. So first, mathematical and logical reasoning. So counting is composed of two abilities that go together. So one is understanding the ranked order of quantities within a sequence. And then the second component is representing those quantities with symbols. Now, the first component is something that comes online fairly early in human development, but it isn't immediate. So human infants typically don't begin to understand the concept of greater than versus less than until sometime between the age of 9 and 11 months. But unlike humans, chickens are a much more precocial species. And it turns out that day-old chicks actually understand the ranked ordering of quantities within a numeric sequence. So in one experiment, chicks were presented with a line of 10 identical covered holes with food placed at a particular, in one hole at a particular position within the line. So some chicks always had food placed in the third hole, some always had food placed in the fourth hole, and some always had food placed in the sixth hole. And since the holes all looked the same and they were covered, the only way that the chicks would be able to learn which hole contained the food is if they could effectively count the holes. And once the chicks had been exposed to this apparatus and had a chance to learn where the food was hidden, when tested, they consistently went to the hole that they had previously learned was associated with food. And they did this even when the apparatus was rotated by 90 degrees, which indicates that they couldn't simply have been using landmark cues in the cage to figure out which hole contained the food. The only way that they could have been able to do this is if they could understand the ordering of the holes within that sequence and effectively count them. So an ability that sort of is one step beyond counting is performing simple arithmetic, for example, addition and subtraction. Now, human children can understand addition and subtraction at a pretty young age, but 12 to 14-month-old children can only do so with numbers up to about up to 3. It turns out that when you try and test children with numbers any higher than 3, they can't keep that in their head, and they just fail completely to understand addition and subtraction with numbers involving 4 or higher. Adult rhesus monkeys perform a little better than 1-year-old human children. They can perform addition and subtraction with numbers up to 4. But newborn chicks can understand arithmetic with numbers at least as high as 5. And I say at least as high because to my knowledge, they haven't actually been tested with numbers any higher than 5. So we don't know the limits of their abilities in this regard. And researchers demonstrated this with a really ingenious experiment where they let chicks imprint on 5 yellow balls. And previous experiments had shown that when chicks were allowed to imprint on a number of balls, they would want to be near as many balls as possible. So they would be motivated to choose the higher quantity of balls in a binary choice test. Then the chicks were placed in front of 2 opaque screens, and different numbers of yellow balls were placed behind each screen in view of the chicks. So for example, the researchers might place 2 balls behind the left screen and 3 behind the right. And then some balls were moved from one screen to the other in view of the chicks. So the chicks could see the balls going behind the screens, but they couldn't see the balls once they were behind the screens. And regardless of how many balls each screen had started with, the chicks were significantly more likely to walk to the screen that ended up with the most balls, indicating that they could understand addition and subtraction with numbers at least as high as 5 because there were 5 balls in total. So then the last sort of non-social cognition that I wanted to talk about is transitive inference. So transitive inference is the ability to understand the logic that if A is greater than B and B is greater than C, then A must also be greater than C. Now, hens have a linear dominance hierarchy where each hen is dominant to the one below her, and there's no reversals in dominance within the order. And this is actually where the term pecking order comes from. We've known for a long time that chickens have this type of dominance hierarchy. And a lot of animals with linear dominance hierarchies have a good reason to be capable of transitive inference, because if you understand that if A is greater than B and B is greater than C, then A must be greater than C, then you can figure out your own position within the dominance hierarchy without having to actually fight every other individual in your social group, which could be very costly. So in one experiment, researchers allowed hens to interact with another conspecific, another hen. So we'll call the brown hen in this slide is the subject, and then hen A is the individual she's interacting with. And A was dominant to the subject. So the subject learned, okay, A beats me in a fight. Then the subject watched A interacting with another hen who we'll call B. And in one condition, A was subordinate to B. So B beat A in a fight. So if the chickens are capable of understanding transitive properties, they should know that they basically have no chance of beating B in a fight because A was dominant to them and B was dominant to A, so B must be dominant to them as well. And that's exactly what happened. When the chickens were put together with B, after watching B defeat A, they never challenged B. But if A defeated B in the original condition, then they would have no way of knowing for sure whether they could dominate B or not. And when put together with B, after seeing B lose to A, the chickens attacked B 50% of the time, which is what you would expect if there was a 50-50 chance of them defeating B. But this doesn't necessarily demonstrate transitive inference. It could, but it could also be that the chickens are following a simpler cognitive rule of never challenge someone if I have only ever seen them win. So because they only ever saw in the first condition, they only ever saw B win. They never saw B lose to anyone. Maybe they were just afraid of B because they were overwhelmed by how often they had seen her win. But another experiment addressed this possibility, this time with young chicks. So they taught chicks an artificial ranked ordering of abstract shapes. So for example, when the chicks were presented with a magenta circle and a brown square, they learned that they would only get food if they pecked the magenta circle. But when they were presented with a brown square and a blue diamond, they would only get food if they pecked the brown square. So on and so forth for the blue diamond and the green cross, and then the green cross and the yellow triangle. So they learned these ranked pairs, but they were never trained with pairs of shapes that are not adjacent in this sequence. So when the chicks were presented with a brown square and a green plus sign together, this was a combination they had never been trained on before. And the only way that they would be able to understand if the brown square was greater than the green plus sign was theoretically if they could understand this transitive property. Although it's a little bit more complicated than that. Some people have come up with some other possible explanations, but that was the idea behind the experiment. They should only be able to understand that brown square is greater than green plus sign if they understand transitive inference. And in fact, the chicks did pick the brown square, indicating that they understand this transitive property. And even without being tested on a given pair of shapes, they understand that the brown square must be greater than the green plus sign because the brown square was greater than the blue diamond, which was greater than the green plus sign. So I think some of the most interesting aspects of chicken intelligence are really in the social realm, because chickens, of course, are highly social birds. And so a lot of their most impressive cognitive abilities are in the area of interacting with others. Like many social animals, chickens are capable of social learning. So in one experiment, hens were trained to peck a specific key to get food. And then naive hens were allowed to observe either a trained hen, an untrained hen, or no one at all. And the naive hens who observed a trained hen learned to peck the correct key much more quickly than hens who observed an untrained hen or no one at all, indicating that they could passively learn by watching another hen. But not only are chickens capable of passive learning, they're also capable of teaching. Teaching is generally thought of as a much more sophisticated ability than simple passive learning. And it's defined as a demonstrator modifying their behavior for the benefit of another naive individual to facilitate the naive individual's learning. So in another experiment, hens were fed two different batches of the same type of food, with each batch dyed a different color. And one of the color foods was sprayed with quinine to make it bitter and unpalatable. And so the hens would learn that one color food was palatable while the other wasn't. And I realize that the colors may not show up as very distinct on the screen, but one batch is green and the other is blue. And they, of course, alternated which color was sprayed with quinine, so there couldn't be any kind of pre-existing bias to one color or the other. Then the hens watched their chicks feeding on food that was dyed both colors. Now, none of the chicks' food had been sprayed with quinine, so the chicks would eat both colors equally. But the hens, of course, didn't know that. And when the hens saw their chicks eating the food that they had come to learn was unpalatable, they pecked at their own food significantly more than when they saw their chicks eating the food that they had learned was palatable. But they didn't actually swallow the food themselves. They just pecked at it without swallowing. So that indicates that the pecking behavior was likely just for the benefit of the chicks to teach them which color food was palatable. Chickens are also capable of something called functionally referential communication. Now, for a long time, animal communication was thought to be purely emotive. That is, it's just an emotional expression of the animal's internal mental state, rather than a signal that refers to something external to the animal. But some of the first evidence that this might not be the case actually came from chickens. So, for example, chickens, or roosters specifically, produce different alarm calls in response to different types of predators. They produce one in response to aerial predators like hawks, and they produce a different type of call in response to ground predators like foxes or raccoons. They also adjust their alarm calling behavior based on the composition of their audience. So when roosters are together with another chicken, they're much more likely to produce an alarm call in response to a predator than when they're by themselves, or even when they're in the presence of a quail. And similarly, when roosters also adjust their alarm calling behavior according to their assessment of their own personal risk. So when they're closer to a shelter, they're more likely to produce longer alarm calls, which are, presumably more effective at warning other chickens, but also make it easier for the predator to find the rooster who's calling. So they adjust their calling behavior according to both the composition of the audience and the risk involved. So this is highly flexible behavior. Roosters also produce food calls as part of a multimodal display called the tidbitting display. So this is kind of what it looks like. He finds a blueberry, starts doing this stereotyped head bobbing behavior together with a call, which you probably can't hear that, but he's making a sort of clucking sound. And then the female comes over and eats the food. So this is a way that they provision their females with food. But you could ask the question, are these calls actually semantic? Do they actually refer to something in the hen's mind? Does she understand that these calls refer to food? Or is it just an automatic response to a stimulus? Whenever the hen sees or hears this tidbitting display, she engages in feeding behavior as a sort of automatic response. So to test this, researchers first played back food calls to hens, and the hens looked down at the ground as if searching for food. That, doesn't indicate one way or the other whether they understand that the food calls refer to food specifically. But the researchers then fed the hens 3 kernels of corn and then played the food call again. And this time the hens did not look down at the ground as if searching for food. So given that the hens were only given 3 kernels of corn, it wasn't that they weren't hungry anymore. Instead, the most logical explanation is that the hens understood that the food call referred to food specifically, and particularly that it referred to the food they had already just found, and therefore they didn't bother searching for it again. And I should clarify that there were control groups where it wasn't always that they first received an alarm call or a food call and then got food and then got another food call. So it can't be that they were just habituating to the sound. There were different groups that received each condition. Now, one ability that's in the realm of social intelligence that's associated with sophisticated cognition and some degree of self-awareness is the ability to understand the perspective of others. And it turns out that when males are producing this tidbitting display, they're highly sensitive to the perspective of other chickens. Specifically, it turns out that hens prefer to mate with males who provide them with more food. And so dominant males will attack subordinates if they see the subordinate making a tidbitting display. And subordinate males are very attentive to the attentional state of the dominant male. So if the dominant male is vigilant, the subordinate males perform their tidbitting display silently so as not to attract his attention. But if the dominant male is distracted, then they'll add the food call back into the tidbitting display as well to make it more attractive to the females. So they're modulating their performance of this display based on their assessment of the attentional state of others. Chickens also engage in something called tactical deception, which is deceiving others for personal gain. Now, it's called tactical deception because it's an evolutionary tactic, meaning that it may or may not involve any conscious intent to deceive. We're just talking about the result of the behavior rather than assuming anything about the chicken's mental state while they're doing it. But regardless of whether the roosters intentionally deceive the hens or not, what they do is they sometimes will produce a tidbitting display in the absence of any food. And the function of this is that this is a form of mate guarding. So when the rooster produces a tidbitting display, the hens will come toward him expecting food. And that prevents the hens from straying too far away to where they might mate with another male. And roosters are more likely to do this if their hens are straying further away from them. But regardless of whether the roosters are intentionally deceiving the hens or not, the hens can certainly learn which roosters are trustworthy and which are not trustworthy. So in one experiment, researchers put roosters and hens in adjacent cages and gave the male food so he would make a tidbitting display. And for some of the males, the researchers fed the female whenever the male made a tidbitting display, so she would come to associate that male with reliable food calling. But for other males, they didn't feed the female when the male made a tidbitting display, so she would come to associate that male with unreliable food calling. And then they put the hens in a separate room individually and played them a life-size live stream video of either a rooster that they had come to see as reliable or a rooster that they had come to see as unreliable. And when played the reliable rooster, the hens looked at the screen for much longer than when played the unreliable rooster, indicating that they can recognize individual roosters from a video display and learn which roosters are trustworthy and which are not, and pay more attention to the roosters that they see as trustworthy. So all of these areas of social intelligence are what behavioral ecologists sometimes call Machiavellian intelligence. In other words, using information about the social environment to benefit yourself, often at the expense of others. But chickens are also capable of pro-social behavior, and in particular, they exhibit certain behaviors that are consistent with feeling empathy. So empathy is defined as the ability to be affected by and share another's emotional state. And it's considered to be a continuum between emotional contagion, which is simply feeling similar emotions to others, so kind of reflecting another's emotion, all the way up to cognitive perspective taking, which is consciously understanding how somebody feels and putting yourself in their shoes, essentially. Now, studying animal emotion is notoriously difficult, of course, but one way that we can do that is to examine behavioral and physiological correlates of certain emotions in humans, and then examine those behaviors and physiological cues in other animals in a similar situation. So in one experiment, hens were placed in one crate with their chicks placed in another, and a clear screen was placed between them. So the hens could see their chicks, but they couldn't reach them. And then the chicks were sprayed with a puff of compressed air, which is an unpleasant stimulus. And when the hens saw their chicks being sprayed with air, they increased their vigilance, they decreased their preening behavior, and their heart rate went up, which are all behaviors that are associated with agitation. When the compressed air was directed off to the side, the hens did not exhibit any of these behaviors, indicating that they weren't simply reacting to the noise of the air canister, but rather to seeing their chicks in distress. And when the hens themselves were sprayed with compressed air, they also exhibited increased vigilance and decreased preening behavior, although their heart rates did not go up as they did when they saw their chicks being sprayed with compressed air. So this suggests that the hens experience an emotional response to seeing their chicks in distress, which indicates that the hens likely experience some kind of emotional contagion from seeing their chicks in a negative situation. Now, there are limits to this empathy. So in a follow-up study, researchers repeated the same experiment with where instead of watching their own chicks, the hens saw other adult hens that they were familiar with but unrelated to. And the hens showed, they did not show the same response. So there was no indication of emotional contagion in that scenario. But this is not too surprising because all species with empathy show variation depending on their relationship to the victim and the severity of the victim's distress. So the final area of cognition that I want to talk about is more related to animals' internal mental states and experiences, consciousness and self-awareness. So there are basically two types of memory: procedural memory and declarative memory. Procedural memory is an unconscious, unthinking set of instructions for how to respond to a stimulus. Our immune system has procedural memory, for example. So when you're exposed to a pathogen, you produce antibodies to that pathogen, and then if you're exposed to that pathogen again, you'll mount a stronger immune response. That's procedural memory. Declarative memory, on the other hand, is a conscious mental representation of the who, what, when, where, and why of a past experience. So in humans, declarative memory uses different neural circuitry from procedural memory, but it uses the same neural circuitry as future planning, which suggests that animals that are capable of declarative memory may also be capable of some concept of the future, although that's certainly not guaranteed, but it suggests that possibility. So to my knowledge, there haven't really been any studies that investigated future planning in chickens directly, although there have in some other birds. But there have been some studies that investigated declarative memory. So in one experiment, hens were placed in an enclosure with two different types of food placed in different corners of the enclosure. One was a batch of rice dyed green and flavored with almond extract, and another was a batch of rice dyed yellow and flavored with banana extract. So after the hens had learned the locations of these two types of food, the hens were taken out of the enclosure and then fed one of the two food types to devalue it. So just like humans, chickens can exhibit specific satiety, meaning that they can get sick of one type of food while remaining hungry for other types of food. So by feeding the hens one type of food, they made them prefer the other type of food. And they tested this to make sure that they genuinely did prefer the other type of food after this devaluing process. Then the hens were placed back in the same enclosure, but this time the food was removed. So the bowls that had previously held the food were still there, and they were covered, so the chickens couldn't see what was in them. But there was actually nothing in there, so there was no possibility of olfactory cues or anything like that. And the hens went immediately to where the banana rice, or whichever rice they had not previously been devalued, had previously been located. Now, if the hens only had procedural memory, they wouldn't be able to for example, if they only had procedural memory, they had like a set of instructions like turn right upon entering the enclosure, some other kind of automatic set of instructions for how to respond to a given stimulus. They wouldn't have been able to do this because they didn't prefer one type of food over the other when they were initially placed in the enclosure. They only developed that preference afterwards. But if they have declarative memory, if they can remember the what and where of a past experience, that explains why they went immediately to the type of food that had not been devalued, because they could remember which type of food was in which location. So that indicates some form of conscious mental representation of past experiences in chickens, or at least it's suggestive of it. Self-control is another ability that is associated with consciousness because it's related to the development of self-awareness and a concept of the future in humans. And self-control develops gradually in human children, and the degree of self-control exhibited depends on the lag time of the delayed gratification and on the value of the reward. And chickens, it turns out, have the capacity for self-control, although just like in children, it varies based on the perceived value of the reward. So for example, in one experiment, chickens were given a choice between pecking one key and getting 3 seconds of access to food after a 2-second delay, or pecking a different key and getting 7 seconds of access to food after a 6-second delay. And in this experiment, the chickens were impulsive. They chose the immediate gratification option. But in a follow-up experiment where the chickens were given a choice between 3 seconds of access to food after a 2-second delay or 22 seconds of access to food after a 6-second delay, they chose the delayed gratification option, indicating that they are capable of self-control, but how much self-control they exhibit depends on how valuable they perceive the reward to be. The final cognitive ability related to self-awareness is mirror self-recognition. And this has long been considered the gold standard test for self-awareness in animals. Basically, the way that it works classically is an animal is exposed to a mirror and allowed to become accustomed to it, typically over a period of several days. Then the animal is anesthetized, and a colored mark, is placed on their body in a part of the body where they would not be able to see it without using a mirror. Then, when the animal wakes up, they're observed without the mirror to see how much they touch and try to remove the mark. Then they're observed in the presence of a mirror to determine whether being able to see the mark in the mirror affects how often they touch or try to remove the mark. And then they're also tested with an invisible mark to control for the possibility that they simply feel the mark on their body. So there aren't very many animals that can pass this test. But the test has been criticized because it seems that it has a large potential for false negatives. That is, animals who fail to pass the test despite being self-aware. And the reason for this is that the test isn't very ecologically relevant to a lot of species. So some animals may simply not be motivated to remove a mark from their body, even if they notice it. And so there's been a call for researchers to develop alternatives to the mirror test that are more ecologically relevant to the behaviors that the animals naturally exhibit. And increasingly, mirror self-recognition is seen as a continuum rather than an all or nothing phenomenon, because there are a lot of species, for example, rhesus monkeys, that exhibit mirror self-recognition under some circumstances, but not others. So it seems that there is some kind of continuum of ability to recognize oneself in a mirror. Now, chickens fail the classic mirror test, but a recent study tried to develop a more ecologically relevant test for chickens. So as I mentioned earlier, roosters give alarm calls to aerial predators like hawks, but they're more likely to do so in the presence of another chicken than when by themselves. So researchers exposed roosters to like a silhouette of a hawk. They flew a cardboard cutout of a hawk over the rooster's head when in 3 different conditions. 1, when he was in the presence of another rooster. 2, when he was by himself. And then 3, when he was in the presence of a mirror. So the idea was that if the roosters see their reflection as another chicken, they should produce alarm calls in that scenario just as often as they do when in the presence of another live chicken. But when by themselves, they shouldn't produce alarm calls or shouldn't produce them as much. But what they found is that the roosters they were significantly more likely to produce alarm calls when in the presence of another chicken compared to when they were in the presence of a mirror. Now, this may not necessarily indicate that the roosters recognize themselves in a mirror. It may be that they simply they stop short of recognizing themselves, but they do understand that the bird in the mirror is not another rooster. And this indicates some degree of ability along this mirror self-recognition continuum, at least. Even if the roosters are not recognizing themselves, they're likely exhibiting some ability along this continuum, at least according to the researchers who see mirror self-recognition as a continuum. So what are the implications for welfare from all of this research on cognition? So one is that greater cognitive complexity generally requires a greater need for enrichment. So animals with who are more cognitively complex often need a more complex environment in order to avoid negative mental states associated with boredom and frustration. Similarly, highly social animals like chickens have a need for normal social relationships. Chickens have very complex social relationships, as we've just seen. And so their welfare is partially dependent on their ability to form these relationships in a natural way. And then finally, the possibility that chickens have a capacity for some degree of mental time travel and self-awareness may indicate that they have an increased capacity for suffering and joy. So, to quote Dr. Carolyn Smith, who's a chicken cognition researcher from Macquarie University, she said, chickens therefore present a scientific challenge as well as an ethical one, given their treatment during commercial food production. Chickens are not mere automata. Instead, they've been shown to possess sophisticated cognitive abilities. This growing body of scientific data could inform a rethinking about the treatment of these animals. So, speaking of commercial food production, I just wanted to talk a little bit about some of the welfare issues inherent to the way that chickens are treated in agriculture. So first, chickens that are raised for meat are typically slaughtered at around 6 weeks of age, and they're bred to grow extremely fast, and therefore they're bred to be very hungry all the time. But of course, for breeding chickens, it's detrimental for them to be allowed to feed ad libitum as much as they want, because if they're allowed to eat this much, they develop health problems like obesity, heart failure, infertility, which of course affect their ability to breed effectively. So typically, the feed of breeder chickens is cut sometimes to about 30% of what they would eat if left to their own devices, which causes chronic hunger and frustration for these birds. They tend to have higher corticosterone levels, indicating an increased stress response. Some studies have found that they spend 50% of their time pecking at an empty feeder, which is a form of stereotyped behavior indicative of chronic stress. And they also have dysfunctional sexual behavior, with some studies finding that up to 80% of copulations with breeder chickens are forced, that the males don't engage in normal courtship behavior, the females don't respond to it normally, so they engage in forced copulations, which can injure the females. And finally, breeder chickens have cognitive impairment, reduced learning ability compared to chickens that are allowed to feed as much as they want. In hatcheries, for chickens of the egg-laying varieties, males are not raised for meat because they don't grow fast enough to be profitable. So they're culled immediately after hatching, typically by being ground up alive. Sometimes they're gassed to death with carbon dioxide, which is also extremely painful, as we'll see. And a few smaller hatcheries even just put them into plastic garbage bags and just leave them to slowly suffocate. The female chicks are typically have the tip of their beak cut off in a process that used to be called debeaking. Now the industry prefers the term beak trimming, but it's essentially the same thing. The tip of their beak is cut off without any painkillers, and this is extremely painful for the chickens because it slices through the sensitive beak tip organ, which is how they sense the world around them. And it's been shown that they have a lot of behavioral indicators of pain and distress after this process, and it can also interfere with their feeding efficiency. Over 80% of egg-laying hens worldwide are kept in battery cages, which are these tiny cages, typically with several birds crammed into a single cage, where the amount of space per bird is typically about 67 square inches, which is less than a single sheet of computer paper. Some places have banned battery cages, recognizing that they're not good for the bird's welfare. And so, for example, the European Union banned battery cages in 2012, but they still allow enriched cages, which are cages that have a perch and nesting material for the birds, but they still only have about 116 square inches of space per hen, which is not enough space to even spread their wings. Similarly, in California, Propositions 2 and 12 regulated the use of cages for hens, and Proposition 12 specifically banned battery cages, or at least it was supposed to. But whether or not this law is actually complied with is somewhat questionable, as some investigations by animal welfare organizations have found lack of compliance, and even though these findings were published, there's been no enforcement of the law. So even when these laws are passed, it's questionable to what degree they're actually implemented. Now, cage-free and free-range systems undoubtedly represent an increase in welfare over battery cage systems, but they're still problematic as well. Cage-free systems don't allow the chickens any access to the outdoors, so they spend their entire lives indoors in typically very crowded conditions. Free-range systems in the United States are required to give the chickens access to the outdoors for at least 51% of their lifetime, but studies have found very uneven and limited use of the range by the chickens. So use of the range has been shown to be correlated with chickens' welfare, but some of the chickens use the range a lot less than others, and the total use of the range is dependent on a lot of factors, especially stocking density. So more crowded conditions, obviously, it's harder for the birds to access the door in the first place, so fewer chickens actually use the range. And sometimes the use of the range can be quite small, like less than 10 to 15%. So chickens raised for meat, typically called broiler chickens, are also kept indoors at very high stocking densities. And because they're bred to grow so quickly, they often develop a lot of health conditions, particularly leg deformities and heart conditions and heart failure as a result of their unnatural growth rate. Also, the way that these chickens are raised typically involves cleaning out the sheds after every new batch of chickens is removed to be slaughtered. So the sheds typically aren't cleaned at any point during a given chicken's lifetime. So that means that ammonia builds up in very high concentrations in the litter and in the air. So they get hock burns from all of the ammonia built up in the litter, or burns on their legs and skin. And it's been shown that ammonia concentrations any higher than 20 parts per million cause severe lung and eye damage to chickens, including pulmonary hemorrhage and even blindness. But a lot of chicken houses have over 30 to 70 parts per million, especially in winter when ventilation is poorer. When chickens are slaughtered, which happens to both egg-laying hens and meat chickens, because egg-laying hens, after maybe about a year and a half of use, their egg production starts to decline, so they're sent to slaughter as well. And typically they're often caught by hand in a lot of production systems, which means that that's highly stressful for the chickens to be caught by hand. And layer hens, which are prone to osteoporosis due to pumping so much of their calcium into their eggshells, have some studies have estimated that about 30% of them have broken bones by the time they reach the slaughterhouse because of the rough handling and their susceptibility to osteoporosis. For all chickens, food is withheld prior to slaughter so that it doesn't contaminate the meat. And typically it's withheld for 8 to 12 hours before slaughter, although in some places like Belgium, for example, it's withheld for up to 24 hours. And also the chickens lack water from the time that the workers begin catching the chickens until they're actually slaughtered, which has been estimated to be about 5 to 7 hours, depending on the particular farm. The slaughter process itself, there are two most common ways that chickens are stunned prior to slaughter. The most common way by far in the United States, we're accounting for about 92% of the chickens killed in the US, is live shackling plus electric stunning. So the chickens are hung upside down while still fully conscious and then dragged through an electric water bath. But studies have found that the settings used on these baths are often ineffective at stunning the chickens. And the reason low settings are used is because there's a trade-off between the effectiveness of the stunning and the quality of the meat. So companies are motivated to use lower amperage, which is less effective at stunning the chickens, but less likely to damage their meat. And in the United States, it's been estimated that over 800,000 chickens per year miss the blade that's supposed to kill them after they're stunned and are drowned or scalded to death in the defeathering tanks that it's basically boiling water that they're dragged through after being killed. So over 800,000 chickens per year scalded to death rather than stunned and killed properly. An alternative method of stunning is controlled atmosphere stunning, where the chickens are put in a chamber and gas, typically carbon dioxide, nitrogen, or argon, is introduced to render them unconscious. And this is considered higher welfare than live shackling and electric stunning. But carbon dioxide is the most common gas used because it's the cheapest. And it's been shown to cause all sorts of welfare issues, particularly air hunger, which is where you're gasping for air, because the way that animals or actually, I'm not 100% sure if that's been shown for chickens. I think it has, but certainly for pigs. Basically, when the way that your body determines that you can't breathe is when you have an excess of carbon dioxide rather than a lack of oxygen. So carbon dioxide causes animals to be highly stressed in engaging in like sort of violent behaviors to try and free themselves. It's definitely not a humane method of stunning. And finally, I just wanted to talk briefly about depopulation, which is where an entire flock of chickens is killed, typically to prevent disease outbreaks, but sometimes for other reasons, if there's just supply chain issues and the farm needs to get rid of their chickens for some reason. So one method of depopulation that is widely used in the industry is ventilation shutdown, where the vents on the chicken house are simply closed. Sometimes heat or carbon dioxide is added, which is called ventilation shutdown plus, but sometimes not. And the time to die in multi-level cage systems, which is most of the cage systems in the US, ranges from between 1.5 to 3 hours and 45 minutes, depending on whether heat and carbon dioxide are added. And ventilation shutdown plus is approved by the American Veterinary Medical Association in constrained circumstances, which increases the industry's willingness to use this method because it's seen as approved by animal welfare professionals. So briefly, I just want to step out of the realm of science and just talk about ethics. So typically when studies have tried to assess how do we improve chicken welfare, they look at it from the perspective of incremental improvements to welfare. So for example, moving from battery cage systems to cage-free systems, or using controlled atmosphere stunning instead of electrical stunning. But I think it's pretty clear that these incremental improvements don't actually represent good welfare for the chickens. They're simply less bad than the alternative. And I think if we genuinely care about the welfare of chickens and other animals, then really the only ethical option is to transition away from the exploitation of animals in the food system entirely. The problem is that welfare will always come second to profit. So no reasonable company would implement welfare reforms that significantly reduce the amount of money that they earn unless they're forced to do so. And any welfare reforms will necessarily be balanced against the ability to produce lots of product in the first place. So there's no, in my mind, there's no way for chickens to have good welfare as long as they're exploited in this way. The only alternative is to just work towards reforming the food system so that we're not relying on animals in the first place, and we're shifting food production towards a plant-based model. And with that, I will take any questions.
Thank you so much for that. That was really interesting. George has a question. Do you think the MSR test results on cleaner Ross fish were valid? Gallup et al. Tried to discount it, but they always do when it doesn't validate their preconceived notions about primate exceptionalism.
Yeah, that's a really good question. So personally, I find the studies on mirror self-recognition and cleaner RAS to be some of the most convincing of any species that's been tested. And part of the original study there were three papers that I'm aware of on mirror self-recognition and cleaner RAS. The first paper, there were some alternative explanations that hadn't yet been ruled out. So there were legitimate criticisms to be made there. But I think the authors very effectively addressed them in their second and third study. And particularly what I find most convincing is that not only do the cleaner RAS recognize themselves in a mirror, But after they've been exposed to a mirror, if you show them a picture, just a photograph of themselves with a mark drawn on their body, they'll rub that part of their body against the substrate as if trying to remove it. But if you show them a photo of a different cleaner ass, they don't do that. So that implies that it's not just like contingency matching of a tactile stimulus plus a visual stimulus, as some people have suggested. They're using only a visual stimulus, and they have a mental image of what their own face looks like from their prior experience with a mirror, and then they can use a purely visual stimulus to determine that something must be on my body and then try to remove it. Yeah, I think that the cleaner ass experiments are really convincing. It's kind of shocking actually because their brains are tiny. And there are a lot of other animals with much, much bigger brains that have not passed the test. But I think it does tell us a lot about that, the assumption that big brains always indicate greater intelligence, and then greater intelligence in some areas um, necessarily implies greater intelligence in other areas. It's not really a valid assumption.
That's interesting. Yeah. And Linda asks, have California's Prop 12 goals been entirely slowed down? Has it been a model for other states, or is it languishing?
That's a good question. I don't know a ton about that. I'm not a policy expert by any means. I do know that, of course, other states, particularly pork producing states like Iowa, were very upset by Prop 12 because it affected whether they could sell their products in California. And it was brought all the way to the Supreme Court. Unfortunately, the Supreme Court upheld the law. But beyond that, I don't really know, to what degree other states have considered similar propositions.
Yeah, I mean, the industry is still trying to fight it and trying to introduce language into the farm bill that would pretty much overturn it. Like, they really hate democracy. So, I mean, it'll be interesting to see how it's enforced too. And I think that'll be up to a lot of activists to enforce it and expose the way that it's not being enforced. And Cheryl asks, were olfactory cues ruled out in the study with chicks finding the correct hole with the food, suggesting that they count, so to speak?
That's a good question. I don't know if you can entirely rule out olfactory cues, because I can't remember off the top of my head if when they tested the chicks, the food was removed. I think they did, but I don't want to say that for certain without looking at that study again. I think the proper way to rule out olfactory cues would be to test the chicks with an apparatus where there was no food at all and just see if they go to the hole where they expected the food to be. But I can't remember for sure if they did that or not.
Yeah. Oh, that's really interesting. All right. Any final questions before we leave? This will be posted on our YouTube. So check us out. Check out our YouTube channel for all of our previous talks. Let's see. Oh, Lauren asks, what do you think about the healthfulness of the current plant-based chicken alternatives that are available on the market? I mean, I don't know if you can speak to that.
That's another good question. Again, I'm not a nutritionist,
Yeah.
so health is definitely not my area of expertise. I would imagine it probably depends on what the alternative is. Um, I think generally speaking, if it's yeah, again, I don't want to make conclusions because it's not my area of expertise. I have, some knowledge about nutrition, but not really any more than the average person. So I don't think that I can really speak to that as an expert.
Yeah. I mean, can we speak to the healthfulness of like the current chickens that are sold, slaughter-based chicken? There's a lot of public health threats with it, and salmonella and campylobacter
Absolutely.
things. So that's a concern. And I think we don't really interrogate the health concerns associated with chicken enough.
Yeah. I mean, just on a personal note, I don't eat chicken, but I also don't eat a ton of chicken alternatives.
Yeah.
I mostly eat, you know, beans, lentils, other things that we know for a fact are good for you. But
Yeah.
that's just my personal choice.
Yeah, same. And I think everybody should have access to delicious, healthy, slaughter-free food personally. And unfortunately, I think
Yeah,
these
agreed.
corporations, these slaughter-based corporations, are limiting our access to that. And Shady asks, thanks to the Welfare Footprint Project, we now know how we could quantify pain in birds. Do you know if it's possible to do something similar with mental welfare, or this would be very in specific, I think she means?
Yeah, I think there are ways to assess mental welfare, but I think with anything that involves assessing the subjective um, the, sub the subjective feelings of an animal, including pain, by the way, there is a certain amount of guesswork involved because we're using cues to their internal mental state. We can't measure the internal mental state directly. But there are a lot of indicators of poor mental health in animals. So, for example, stereotyped behavior is one of them, where animals engage in repeated behaviors that follow a very specific pattern that don't have any purpose. So, for example, the breeder chickens that I talked about that spend 50% of their time pecking at an empty feeder, that's a stereotyped behavior. And stereotyped behaviors, at least in mammals, it's been shown that it results from brain dysregulation that's caused by stress. So chronic stress means that there's chronically elevated levels of corticosterone in birds, or cortisol in many mammals, which affects the neural pathways in parts of the midbrain. And at least in mammals, that's what results in stereotyped behavior. So it's not quite brain damage, it's like dysregulation of the functioning of the brain. And it's a very good indicator that an animal is not experiencing good mental welfare. There are others as well, a lot of, mostly behavioral indicators. Some people have also tried to use artificial intelligence to assess the vocal properties of animals' calls, the acoustic properties of animals' calls. So certain acoustic properties are generally associated with increased stress or pain. For example, at least in mammals, higher pitched sounds, more modulated fundamental frequency of the sound, more entropy in the vocalization. Those are all associated with stress, and in certain circumstances with poor welfare. So some people have tried to devise systems to measure that using artificial intelligence. But yeah, there's a lot of ways to get at it, but I think, like I said before, you can measure welfare as much as you want in farms. You can try and incrementally improve it with reforms that kind of chip away at the edges of the negative welfare that animals are experiencing, but you can't ameliorate it. You can't reduce the bad welfare that they're experiencing, or you can't eliminate the bad welfare that they're experiencing. You can only make it slightly less bad. The only way to actually treat the animals humanely is to not raise them commercially and kill them in the first place.
Yeah, that makes sense. And we don't really need to anymore. So it's like, and it's kind of frustrating that
Exactly.
these large corporations are getting so much of our taxpayer dollars, whether we pay for their products or not. And the bird flu bailout's a big example of that. Jenny O Turkey Store got $85 million of our money. Tyson Foods got $29 million. And they killed their animals in mass via heat stroke in response to avian influenza. And now more than 2,000 veterinarians have signed on to Veterinarians Against Ventilation Shutdown. If you're interested in that, please share it with your veterinarian. Go to vavsd.org to learn more about that. You can sign on, but definitely share it with your veterinarian, because so many veterinarians still don't know about ventilation shutdown and how it's used to kill animals, and how much of their money is going to support these very wealthy corporations who do this to animals. So thank you all so much for coming. That's it. If there's no more questions, I'll end it. But oh, Kim has a hand raised, and feel free to unmute yourself if you want to ask a question in the chat or whatever. Oh, I'm asking you to unmute, or not, or I'll end it. All right, I'll talk to y'all later, and see you next time. Bye.
Bye. Thank you.